Welcome to the cockpit overview lesson. Today, we will take a detailed look at the Mustang cockpit. You can use mouse look mode to move your view around the cockpit. To turn mouse look mode on and off, press left Alt plus C. Throughout this lesson, pressing the spacebar key will initiate the next consecutive step once instructions for the current one are complete. Press the spacebar key when you are ready to begin. The cockpit is configured in a standard layout, with the instrument panel positioned on the front dash, a center-mounted control stick, a throttle quadrant on the left side, and various aircraft system controls on the left and right panels. With the exception of the flaps control handle, which is located in the bottom left corner of the cockpit, most of the indicators and controls are well organized and easy to read and reach. Moving on to the instrument panel, the upper left corner houses the remote indicating compass. The compass unit is installed inside the left wing and transmits magnetic readings electrically to the cockpit indicator. Using a remote compass avoids the magnetic effects caused by armor plating around the cockpit, experienced by a standard magnetic compass. The remote indicating compass includes a heading needle, which shows the current heading, and a desired heading needle, which can be turned using the indicator knob to set a desired course reference on the indicator. To turn the knob, you can simply roll the mouse wheel over it. To the right of the remote indicating compass is a standard clock. The winding knob can be used to set the time. Doing so requires pulling the knob out with the left mouse button, then rolling the mouse wheel over the knob to rotate it. The suction gauge indicates the amount of pressure in inches of mercury being generated by the engine vacuum pump. Vacuum pressure is used by a number of vital instruments, including the flight indicator, bank and turn indicator, and the directional gyro. A suction reading above or below normal means the readings of these indicators are unreliable. Next is the manifold pressure indicator. This is one of the primary instruments used in flight, and together with the tachometer or engine RPM indicator is your main reference of engine power. The manifold pressure indicator shows gas pressure inside the engine induction system prior to entering the cylinders. Like the suction gauge, the indication is in inches of mercury. Manifold pressure is set using the throttle handle, while engine RPM is set using the propeller control lever, also on the throttle quadrant. On the left side of the middle row of the instrument panel is the airspeed indicator, which shows an indicated airspeed in miles per hour, mph. The red line on the indicator marks the maximum permissible airspeed of 505 miles per hour. It's important to remember that maximum permissible indicated airspeed is reduced as altitude increases. For example, it is 400 mph at 20,000 feet and 300 mph at 30,000 feet. In the left center of the instrument panel is the directional gyro, which shows current heading. The instrument can be caged and the heading adjusted manually by pushing in and rotating the indicator knob. In the center right of the instrument panel is the flight indicator, which shows the aircraft's roll and pitch attitude relative to the horizon. The indicator is limited to 60 degrees in pitch and 100 degrees in roll. The instrument can be caged or uncaged using the caging knob in the lower right corner of the indicator. The horizon level can be adjusted vertically using the pitch adjust knob. To the right of the flight indicator are two temperature gauges, the coolant temperature gauge above and the carburetor air temperature below. It's important to monitor these instruments in flight, as temperatures rising above normal may lead to serious engine problems, such as detonation and pre-ignition. On the right side of the middle row of the instrument panel is the tachometer. This instrument indicates engine speed in revolutions per minute, RPM. The pilot controls engine speed using the propeller control lever on the throttle quadrant. A propeller governor system automatically adjusts propeller pitch angles to maintain the RPM set by the pilot. Typical RPM settings in flight will be between 1,800 and 3,000 RPM. Moving to the bottom row of the instrument panel, The left corner houses the altimeter. The altimeter shows barometric or pressure altitude using a 3-needle system. The shortest needle shows altitude in tens of thousands of feet, the middle needle in thousands of feet, and the longest needle in hundreds of feet. The indicator knob is used to adjust the sea level reference pressure in inches of mercury to ensure an accurate altitude reading over a desired location where the sea level air pressure is known. Next is the bank and turn indicator, primarily used to maintain coordinated flight and minimize side slip. The vertical needle of the instrument indicates turn rate, and the slip ball indicates side slip or side skid. In flight, the pilot maintains the ball's center by using stick and rudder controls or aileron and rudder trim. Flight trim is very sensitive to changes in engine power and airspeed, so constant attention must be paid to the bank and turn indicator in order to fly as efficiently as possible. To the right is the rate of climb indicator, which shows the climb rate in thousands of feet per minute. Further to the right is the accelerometer, or G-meter. This indicator shows the G-load factor experienced by the aircraft, as well as 2 additional needles that show the maximum and minimum G-loads attained since the instrument was last reset. The instrument includes a reset button used to reset the needles to 0. Finally, on the very right is the engine gauge. This instrument includes 3 indicators: the oil temperature gauge, oil pressure gauge, and the fuel pressure gauge. Moving below the instrument panel, the engine control panel includes a number of important engine controls. These include supercharger blower switch, sets the supercharger to low, high, or automatic blower modes. Normally this should be set to auto. The jewel light indicator lights up when the supercharger kicks into high blower mode. Fuel booster switch, turns the fuel booster pumps on and off. Oil dilute switch, used to dilute the oil with gasoline, which may be necessary when starting in cold temperatures. Starter switch, used to turn the engine prior to ignition during startup. Primer switch, used to feed fuel to the engine through the fuel primer system during startup. To the right are the 2 landing gear warning lights. These indicate safe or unsafe states of the landing gear. For example, the unsafe red light will be on if the gear doors are open but the landing gear is unlocked. Adjacent to the landing gear warning light is the parking brake handle. Setting the parking brake requires the following steps. Pull out and hold the parking brake handle. Fully depress and release the brakes. Release the parking brake handle. Releasing the parking brake only requires a press of the brake pedals. On the right side below the instrument panel are the oxygen indicators, the oxygen flow indicator, and the oxygen pressure gauge. The oxygen flow indicator features a blinker that opens and closes as the pilot inhales and exhales on-demand oxygen. The oxygen pressure gauge shows the amount of oxygen remaining in the O2 tanks in pounds per square inch, psi. A normal reading is 400 psi. Just below the instrument panel is the front switch panel, which includes a variety of important controls. Ignition selector switch selects the left, right, or both magnetos to operate the engine ignition system. Cockpit light switch turns on and adjusts the cockpit floodlights. Horn silence button silences the AN/APS-13 rear warning radar alarm. Below the front switch panel is the fuel control panel. This includes the fuel shutoff valve, used to open and close the fuel flow, and the fuel selector valve, used to select the fuel tank used to feed the engine. Correct fuel tank selection is important in flight to maintain a balanced aircraft. To the right of the fuel control panel are the hydraulic pressure gauge and the landing gear fairing doors emergency release handle. The landing gear fairing doors emergency release handle can be used to release the hydraulic pressure and mechanical locks holding the gear doors closed. This will open the fairing doors and allow the landing gear to fall down under its own weight. Slight rolling of the aircraft from side to side can be used to ensure the gear locks in place prior to landing. Normal pressure for the hydraulic system is 800 to 1100 psi. The surface control lock is used to lock the control stick in place when the aircraft is parked. Left-clicking over the pin locks the stick in the forward position, which leaves the tail wheel unlocked and allows the aircraft to be towed and turned easily. Right-clicking on the pin locks the stick in the neutral position, which leaves the tail wheel limited to 6 degrees of turn. Moving to the left side of the cockpit, the throttle quadrant dominates the forward section. The throttle quadrant includes the throttle handle, the propeller control lever, and the mixture control lever. In addition, two friction locks are mounted on the assembly and can be used to stop the movement of the throttle handle or the mixture and propeller control levers. The throttle handle features a microphone switch button used to activate transmission over the VHF radio. Moving back from the throttle quadrant, the radiator air control panel includes switches to operate the coolant and oil radiator flap doors. These are usually kept in automatic, but can be opened and closed manually when necessary. This panel also includes the landing light switch and the left-hand fluorescent light rheostat switch, which controls instrument backlighting on the left side of the cockpit. 3 trim wheels are used to set the aileron, rudder, and elevator trim. Take off with 5 to 6 degrees of right rudder trim to help compensate for engine torque. Trim settings in flight may vary depending on flight conditions. The 2 handles toward the left rear of the cockpit control airflow to the engine induction system. The ram air control handle controls whether air is ingested through the main intake under the nose or filtered intakes on either side of the nose. Filtered air is used when icing of the intake develops. The hot air control handle opens a vent door in the engine compartment to allow warm air to enter the carburetor. This can be done below 12,000 feet when icing of the carburetor is a danger. Probably the most awkward control in the cockpit is the flaps control handle in the bottom left corner. The flaps can be set from 0 to 47 marked 50 degrees in 10-degree increments. The landing gear control handle is also on the left side. The handle is pulled in and moved up or down to raise and lower the landing gear as desired. The gear should only be moved when it's locked in either the up or down position. Now moving on to the right side of the cockpit, we have 2 canopy controls. The canopy is rolled open and closed by turning the canopy hand crank. The red handle is the emergency canopy release. When pulled, this will unlock the canopy and it will fly off into the slipstream. The oxygen regulator is used to control oxygen flow to the pilot's mask. The oxygen diluter lever, marked with yellow stripes, is used to set normal diluted oxygen or 100% oxygen. The red emergency valve is a separate backup oxygen line and can be used to bypass the regulator. The recognition light's keying switch is used to flash the recognition lights installed on the underside of the right wingtip when they are set to key mode on the electrical panel. The lights turn on for as long as the keying switch is held down and off when it is released. The electrical control panel includes switches for battery and generator power, pitot tube, and external lighting. In addition, the right-hand fluorescent light rheostat switch controls the backlighting for instruments on the right side of the cockpit. The electrical control panel also includes an important indicator, the ammeter. This shows current output of the generator in amperes. Maximum permissible output is 100 amperes. The ammeter does not show battery current. Finally, the electrical control panel also includes a circuit breaker bump plate. This can be pressed in to reset all the circuit breakers in case one or more of them gets overloaded and pops out. Further back from the electrical control panel is the AN/APS 13 Rear Warning Radar, or RWR. This device sounds an alarm when an object is detected behind the aircraft to warn the pilot of a possible threat approaching from the rear. Next is the SCR-522 VHF radio, used for communication with flight members and air traffic controllers. The radio features 5 channels, the frequencies for which are preset and cannot be changed in flight. You should consult your mission briefing prior to starting a flight to ensure your radio is set up to contact ATC towers in your vicinity. The remaining radio systems, including the homing adapter, IFF transponder, and Detroller range receiver, are not functional in this aircraft. Let's now take a look at the fuel gauges. You may need to twist your head around the cockpit a little to see them. You can press left Alt plus C to enable mouse view mode, and then hold down the mouse wheel while moving the mouse to move your head around the cockpit. The gauges for the left and right main tanks are located on the floor to either side of the seat. Finally, the area under the seat also houses cockpit environmental controls, including windshield defrosting and cockpit heating and cooling. This concludes the cockpit overview lesson. Next time, we'll learn how to start her up.